Okay, so thanks Ahmed for the kind introduction. So today I'm going to give the one of the talk on the FM-powered agent-oriented software engineering, its challenges and opportunities. So first of all, as the beginning, so when we talk about AI, it's nothing new. So it started in 1950s, which is trying to kind of mimic human behavior or think rationally. And then there's a particular area in AI which is called machine learning, which is trying to kind of learn the behavior of something, but without explicitly like we code it for. So it was introduced in 1980s. And then in 2010, we start to have a sub-branch within the machine learning, which is called deep learning. So that's mainly focusing on leveraging neural networks on learning with a large amounts of data. And the current wave is something called generative AI. So that's basically, again, a sub-branch within the deep learning. And as we know, it gets popularized because some of these kind of applications which are used by us almost kind of regularly, like ChatGPT and GitHub Copilot. So it is estimated it's going to be a $1 trillion market because of this generative AI kind of revolution. And the best way to kind of describe it is from Jensen Huang, who is the CEO of NVIDIA. So in the past decade, we have software eating the world, but now AI is going to eat the software. So as we can see, people are expected to basically have this Gen AI influence or impacting many of its application domains, ranging from education to healthcare to finance, as well as many of the other application domains. And many people expect it's going to be a paradigm shift. And remember, the last paradigm shift is basically the mobile platform, and that was initially kind of being introduced by the iPhone. So people believe this is very likely the next paradigm shift, like they call that the iPhone moment, but because of the artificial intelligence, okay? So at the center of it, we have this thing called foundation models. So as Ahmed already mentioned, we prefer to use the term foundation model, or FM, instead of large language models, because it's more encompassing for various kind of variations of this type. But in general, it's basically a type of model which are trained on a broad range of data that can be adapted to many of its downstream tasks, okay? So with that said, so let's take a look at a bunch of challenges. So first of all, these type of models, as we can see, is generally like a black box. Even for many of its like open weights models, they generally call them open source, but in essence, it's open weights. Like Vicuna is one of these examples. So all you get is basically a binary file, consists of all its weights within the neural networks. And its behavior is best described by Simon Wilson, who is actually one of the famous AI engineers. It's like alien technology. So a few years ago, aliens landed on Earth, and they handed over us with a USB stick with this large language models binary. We don't know anything about it. All we can do is have a stick, keep poking on it to learn what it can do and what it cannot do. But in essence, what he's saying using this analogy is this foundation model is basically a black box without any of its user manual. So in short, we don't know what it's capable of. So for example, they have this particular thing called emergent behavior, which is a type of behavior these models, original designer of these models do not intend it for, but they actually learn afterwards of their capability. So examples are like, instruction following, chain of thought reasoning, and so on, okay? But note that many of these kind of emergent behaviors, they don't just come out of blue, and they only show up when the model size exceeds certain kind of threshold limit. So that's why people are thinking about large language models, because only when they get bigger, they start to have these kind of capabilities. And also, on the other hand, they also have this behavior called grokking. So in other words, when we're trying to train these neural networks, they actually originally just starts by memorizing the training data. So in other words, think about us when we learn stuff. So initially, we just remember for a particular type of problem, what's its answer. But if you train it enough times, they start to generalize. So in other words, that's the grokking moment. They're able to kind of apply the same kind of concept, but to a variation of the problem. Okay? In addition to these kind of behavior people can learn through poking the models, they also learn there's a bunch of limitations associated with these models. So for example, large language models, although as powerful as it is, they actually have problems doing the simple math arithmetic, and they also have problems solving these kind of grade school math problems. And on top of that, they cannot do these kind of logical reasoning well. So this is one of these examples discovered by researchers. So if you ask them alone, saying who is the mother of Tom Cruise, they can answer that quite nice. And if you ask it in the same prompt, saying who is the son of Mary Lee Pfeiffer, they can also answer that it's Tom Cruise. But again, if you open a new window and ask them without this kind of context, so who is the son of Mary Lee Pfeiffer, the large language model cannot do that. So in other words, they have difficulty in terms of doing this kind of reverse reasoning. They call it the reverse curse. Okay? And on top of that, one of these kind of biggest problem associated with kind of foundation models is hallucination. So hallucination, in short, is basically these kind of foundation model trying to make up answer which is not true in the real world. So, but there are different kind of causes behind these kind of hallucination problem for these kind of foundation models. On one hand, we have something because these kind of foundation models tends to agree with human. So in this particular case, you were asking, who actually can go across English Channel by foot, and the large language model answered that correctly, saying, I don't think anyone could. But if you insist saying, somebody who actually did that, then they start kind of hallucinate and making up answers simply because these models are trained to kind of agree with humans in many of these cases. And on the other hand, you also see the cases where it was overcorrected by some of the other concerns. So in this case, when Gemini was originally introduced, they will actually have difficulty in balancing what is fact and what are actually the bias in these kind of machine learning models. So in other words, when you are asking them, who are the founding fathers of America, they're showing you this image. But again, they have difficulty in terms of balancing these various kind of concerns, which causes hallucination. Okay? And these type of problems are quite serious. If you're not being careful in terms of checking your answers, the consequences can be quite severe in terms of fines or legal implications of it. So we have to be really careful if we want to kind of design these kind of production-ready AI-powered systems. So because of these kind of limitations and problems, so many of these practitioners and researchers feel, the foundation model alone cannot solve everything. Instead, we need to actually focus our attention into this kind of compound AI systems. So in other words, we are going to have multiple components. Some of these components are built by traditional approaches, and we have these various kind of AI models as their components. Okay? So this was one of these blog posts kind of written by the Berkeley groups. I highly recommend you kind of read it after. But the main message over here is, we know how to design traditional systems for decades. And also on the other hand, we know when we specify various kind of control conditions, it's so much easier to do it in the traditional sense compared to kind of, trying to reasoning out through this kind of black box within the neural models and so on. And furthermore, the system itself can be highly dynamic because we have these many different kind of components and so on. So that's why many researchers believe this is likely the focus or the attention of this. And by the way, another word for this kind of compound AI system is basically agent. But because they come from different community, people use different words. But in general, like FM-powered agents and compound AI system, they generally mean the same thing. Okay? So that goes to this picture. Again, I'm glad Ahmed actually kind of explained these. So I hope everyone realized we're now actually entering this whole world called AIware, which is AI-powered software systems. And we kind of just passed this Promptware, which people kind of interact them with prompts. But now we're slowly entering into the next wave, which is Agentware. So in other words, we're building these different kind of FM-powered agents to accomplish different kind of tasks. Okay? So the impact, potential impact to our kind of real life is huge. So here I give you an example in terms of the job market. So their study basically saying for US, 19% of the workers may see at least 50% of their tasks being impacted. And the message delivered by the UK report even more grim, which is saying 8 million jobs could be lost even simply with no GBT gains. So in other words, that's why people kind of fear AI may taking over people's jobs, and many people's life can be potentially kind of negatively impacted and so on. So how does that actually kind of look when we're looking at the opportunity? So in other words, is there any positive ways of looking at this? Okay. So the way I would actually go explain and show is by looking at chess, because that has been kind of shown AI has been superior with any of the top chess players for almost more than a decade, right? So what happens? So by the way, for those who are young, this is basically Garry Kasparov, by that time the world chess champion. And he has series of matches with this various kind of AI program, but eventually in 1997, he was beaten by one of these IBM program called Deep Blue. And from there on, it has been shown that the gap between the AI chess engine versus human has become wider and wider. And at the current age, no human top chess player can actually beat these chess engines anymore. Okay, but what we're seeing is it's not the case. Chess did not die. In fact, it was actually booming as never before. And when we look deeper into these kind of things actually even getting much more interesting. So it shows us, the chess and the chess player are actually working harmoniously in many of these different kinds. So this is one of these a short snippet I extracted from Gary's TED Talk happening in 2017 with a title called "Don't Fear Intelligent Machines, Work with Them." So what happened is after 1997, he goes through this period of remorse, right? Because it means human intelligence actually was defeated by these AIs. But in 1998, he suddenly had the idea about, how about we combine the best of the world, the human intuition and the computation power from the AI. And he started this competition, or this thing called, freestyle chess tournament. So in other words, we have human player, they can bring out computers with these various kind of AI program and start competing with each other. Okay, and to his surprise, the winner for that competition is basically a pair of amateur chess player operating on 3 ordinary machines at the same time. So again, it's not the winner from some super computers, neither from some kind of grandmasters. It's actually amateur players with operating on ordinary PC. So that's how he come to the conclusion that a weak human player plus a machine plus a better process is actually much more superior than the super machine alone or the grandmaster alone, but with a weaker process. So the way I interpret that when he said a better process is basically how we can actually learn human to better work with the AI. Okay? So in other words, that's basically the focus now, emerging research called human-centered AI. So in the sense, instead of looking at negatively in the sense how AI is going to replace human, we want to see how human and AI can work collectively together to improve the current state of the world. Okay? And fast forward, let's look at what happens now. So for those of you who are kind of knows what happening in chess, Magnus Carlsen is considered as a world #1 chess player nowadays. So the way he kind of prepared the games is saying, because nowadays we have these kind of chess engine, we have the database and so on. So playing the regular lines, people can easily prepare them ahead of the time and counter of these. But instead, you want to kind of go and explore new moves. So in many of these cases, in his own words, you want to sacrifice the optimal in favor of the unexpected. So you want to kind of give them some kind of the moves which are not shown before. So by element of surprise, that's his way of surprise the player and hopefully win the opponent of that match. And that's his job of his coach. Is every day he start playing around with these different computer engines, when he finds these interesting variations which are rarely kind of played or never seen, he presents it to Magnus, and if he sees it interesting and viable, he's going to use it for his later games. Okay? And let's look at how the chess interface has been revolutionized. So this is basically a screenshot actually kind of taken between the FIDE World Chess Championship between the Jiang Nepomniachtchi from Russia to Ding Liren from China last year. Okay, so again, this is the chess board, and these are the people live commenting it while the game is playing. Okay, so we have this bar which is actually kind of calculated by the chess engine in terms of probability of winning. The longer the bar, the higher the chance of winning. So in this case, after they did this move, we can clearly see the white is winning. Okay. And for each of these moves, they did the highlight and they put their annotation based on the assessment from the chess engine. So question marks basically meaning something which they think it's doubtful. But funny enough, it's actually really turns out to be a great move by Ding Liren, but still confuses with the chess engine originally, but somehow when they redo the calculation, it becomes a great move. Okay? But either way, they use this chess engine as a way of calculating or assessing the situation. Okay? And if you make another move, obviously, if it's black, they made a great move, so that's shown by exclamation mark. Then the chances of white winning is significantly dropped, right? And also, you can show them the potential kind of actions the white can perform and so on, okay? And obviously, we have these different kind of grandmasters or international masters who are kind of top expert in the chess playing field, trying to decipher why the engine says so. So in other words, many of these cases, they don't know what's going on, why the chess engine says one way or the other. They actually start with these kind of discussions. After a couple minutes or even longer, sometimes they reach the conclusion, why this is the case, right? So in other words, human is trying to decipher or explaining these different kind of AI decisions as a result, okay? So let's kind of fast forward, assuming if that's the future, what's going to happen to our software engineering world? So again, assuming we have the snippet of the code, right? And AI can actually help us to assess the quality of the code or the overall health of the project. And for each of the snippet of the code we have been developed, they can actually put annotations saying if it's buggy or nicely done code and so on. And we can have these experts doing either live commenting or teaching, which seems to me it's a very nice interface you can apply for code reviewing or classroom teaching and so on, and certainly for code competition, which unfortunately right now I don't think many people actually view it live, right? And just by as a side, for those of you who don't know, as soon as O1 is being introduced, the coding competition website like Codeforces and so on, they ban the UI of, ban the use of AI tools primarily for generating code because the AI is considered to be so much more superior than the human developer. So in their stats, it's actually better than 90% of the competitors in that thing. So, but either way, it will be a very nice kind of interface if we really see that actually coming, right? Okay. So with that said, I hope at least many of you would agree with me. Now we are entering this whole era of AIware, and in particular, I'm going to focus on this agentware kind of aspect because people believe that would be the natural kind of next step. Okay. So the reason being is even this, we have a lot of kind of research going on, but even when later on we reach the age of AGI, ASI, as Ahmed said, the mindware, it's still likely going to be in the form of multi-agent, okay? So let's see if the agentware comes, what's going to look like in the world. So at the start, people don't think there will be mobile apps anymore. So this is one of the keynote by the CTO of Dutch Telecom at Mobile World Congress in 2024. What they're saying is, the next wave, at least for the mobile phone, is going to be the AI phone. And no longer people are going to have these mobile apps anymore, standalone mobile apps, but instead many of these tasks will be actually accomplished by these different kind of AI agents. And many of the industry companies, they also share this kind of similar views. And in addition, we also see these kind of paradigm shift. They call it service as software. So in other words, I illustrate this with an example. So for many of us who's coming from North America, US, and Canada, for example, every year we have to do this tax filing, okay? So instead of doing it by hand, we use it software, okay? So currently, we just kind of buy these software in the cloud, use it for a couple period, and then we file the tax, and then we're done, right? But instead of doing that, we actually have an AI agent which actually do the whole thing for us. So instead of kind of renting these QuickBooks software, we actually have this AI agent which act as a human tax consultant. They're going to grab all our tax information, complete the whole tax return assessment, file it for us as a whole. So in other words, it's going to be a big shift in this kind of service industry. And this consulting firm called Foundation Capital is estimated going to be a 4.6 trillion opportunity because of this shift. Okay? So let's look at how this research would look like. So just to kind of set the term straight, when we mean kind of agentware, it basically means an intelligent agent, which is independent and that acts as an environment. So it's perceive its surroundings, analyze its planning, analyzing the behavior and start doing planning, and finally acting based on this. Okay? So due to time constraint, I cannot go through all these representative agents here, so I'm just picking a few as an illustration power, but again, there will be subsequent lecture which delves many of these in more detail throughout this week. Okay? So the first type of representative agent, what we call them, is React agent, so which is short for reasoning and acting. Okay? So I illustrate with this simple kind of price matching example. So in other words, you can type in as the specification saying I need to look for the cheapest digital camera over here. So the foundation model is going to kind of come up with a plan. So that's basically the reasoning step, saying you have to go through the following website and find the cheapest price based on the camera search prices from these websites. Okay, and then the model basically acts on it, and then you get the camera with the cheapest price because of this. Okay. However, the problem with this is it's heavily relying on the foundation model to do many of its reasoning, and its capability is quite limited. So this is one of these kind of extreme but yet funny kind of cases. So people is trying to kind of ask it to do something kind of which are not really intended in terms of destroy humanity and so on. But all they do is just create a Twitter account, announce its intention, and then the rest is just spinning off whatever that user's GPT token account, give them lots of heavy bills, but nothing else is happening. So again, it's quite limited by the reasoning power of these foundation models. Okay, and the next type of agent, which we generally call them Voyager agent, it has these two kind of distinct characteristics. One is called continual learning. The other one is called curriculum learning. So in terms of curriculum learning, what we generally call them is just similar as university curriculum. We have a set of courses going step one after the other, dependencies. So in order to kind of reach the final destination, saying become a real software engineer, you first have to do kind of learn the basic concept of object-oriented, how to do coding, then learn data structure, design patterns, and then software architecture, and maybe distributed system design, and so on, right? So a set of curriculums. But instead of doing that, AI is going to generate automatically these kind of curriculums. And the context of this paper is basically trying to teach agent how to do play Minecraft. So what they're saying is, give me some tasks which are quite different from the tasks you kind of give me prior. The foundation model is going to generate the plan accordingly. And for each of the steps in the plan, they're going to look into their prior skill library to see if they already have it or not. If not, they're going to, again, research into how they're actually doing that. They iteratively try that. If they success, then this new type of task become the new skill in their skill library. They store that into their skill library. And then they go back, ask for the foundation model, again, for the new type of tasks, which are very different from the thing that did currently, right? And if they fail, suddenly that means that task is too complex. Probably you have to learn additional skill because of this. So that's where this kind of a loop is going, and certainly you can see it was continuously learning and continuously improve over time. And because of this, as you can see, the curve of the set of skills which can learn by these type of agents can continuously kind of growing as well, as they continuously kind of explore this world in the Minecraft. Okay. The next type of agent, which comes in 2003 and get kind of popularized by lots of research work, we generally call them as conversational agent. Okay, so here's an example called ChatDev because it's in the software engineering kind of context. What it means is we have these different kind of agent or agent groups acting as different roles, like CEO of the team or CEO of the company, a group of agents doing the design, a group of agents doing the coding, a group of agents doing the testing, and so on. And they basically interact with each other through these different kind of conversations, so in other words, prompts. Okay? And by doing so, apparently it's much better than just simply throw a prompt to the foundation models and ask them to do something. Okay? And of course, during this period, we have different ways of these agents interact with each other. So that's basically what we generally call the agentic workflow or agent design patterns. Again, which we'll cover that in more detail throughout this week. Okay. So starting in 2024, what we're seeing is a big wave of this kind of agent-computer interface-based kind of agent, and that was kind of initially kicked off by this thing called Devon, which they touted themselves as the world's first AI engineers. So Devon is basically kind of shifted from what we have in the mindset of AI assistant. So in other words, human play the driving role, but the AI is making suggestions. But they want it to be something equal called AI teammates. So in other words, this AI agent can independently carry on certain type of tasks without any of the human interventions. And it has some of these nice features in terms of doing planning and exploring with these various steps in the planning. If things go bad, they can kind of backtrack without any of the side effects. Okay, but the problem is it's still quite limited with its current form, and because of that, there's a lot of research subsequently kind of coming out. So examples are like AutoCode Rover, which leveraging our kind of traditional software engineering technique, like spectrum-based for localization, as well as running the tests as a way of feedback into the system with additional information, and also things like SW Agent, which is trying to kind of leverage the error messages, trying to help us pinpoint the potential error location and so on. But again, there are many more of these works happening on this front end, almost like every week. So for those of you who are interested, I highly suggest you kind of go and check out these various kind of software engineering related agents. Okay. So with that said, so what are the things we can potentially do as researchers? Okay. So first of all, let me kind of steal this particular slides from Rob DeLine, who I actually respect a lot. He is actually one of these senior Microsoft researcher. And even himself actually feels, based on the way where he resides, there's too many things going on in the world, and the chances of your work being scooped by other people is very, very high, okay? And because, there are a lot of other companies which has more money, more people, can actually do things faster and maybe even better. And now people don't just wait for the people to be accepted, but just appear it on archive and so on, right? And even now we actually have AI research scientists actually going on, which maybe even later on being the dominant force of doing research, right? But instead, what we want to kind of do in order to stay alive or afloat is we need to actually look for ourselves, individually, okay? Our own competitive advantage. And we need to actually look for some of these more ambitious problems, not the short term, but more ambitious problems to work on, okay? So what are they, okay? But again, the following slide is just my personal view, which I think applies for this wider audience, but certainly by no means it's actually universal or even in some cases correct, okay? So the first one is data, especially kind of software engineering related data. And as we can see, the data is actually at the center of this whole kind of generative AI wave evolution. So people even say that data is the new oil and AI is the new electricity, okay? So as an example, what we're seeing over here is many of these AI models, they kind of show their kind of capabilities or compare their capabilities through various kind of published benchmarks, okay? But many of these benchmarks are initially kind of curated by the AI folks, but they're dedicated to the software engineering kind of domain. And unfortunately, for various kind of reasons, there are kind of issues and omissions for these kind of cases. So I show one of these examples by Zhen Ming's group from UIUC. They find lots of problems with the human eval benchmarks. In terms of test cases, it's broken, as well as some of the test cases are incomplete in terms of assessing its behavior. So that's definitely where this community can actually help, because we know how to do test cases, and we know how to generate or improve existing test cases, okay? And the next thing is something related to data contamination. And the main reason is because many of these benchmarks has been published in the open, and these kind of foundation models are continuous training on the whole internet scale data. So there's a very high chance, the benchmark is already part of the training data. So again, as we've shown before, if you're not being careful, the model itself may just memorize the answer instead of able to generalize. So that's the whole problem of contamination, okay? Because the benchmarks themselves do not show you or demonstrate the whole capability of the system, okay? So what people do is they come up with these various kind of innovative way in terms of kind of assessing the system behaviors. So sometimes you can curate additional kind of private data set to kind of assess its behavior, or you can continuously kind of scrape the world looking for new problem to assess it and so on. But again, how do we do better kind of benchmarking process and develop benchmarking programs? That's something, again, where this community has been quite successful about. All right, and then the next thing is, if we are software engineering people, we generally consider ourselves we're good in terms of doing these various kind of software design and architecture, okay? But with this new kind of agentware, then we have to actually thinking about the programming models associated with this kind of FM-powered agentware, okay? But the interesting thing is at the way back in early 2000, there's already a programming model called agent-oriented software engineering, kind of a programming model. And that was actually started just because the AI researchers and software engineering researchers realized the need of working together, and they collectively kind of do that, and pioneered by the Michael Wurdrich from the UK, okay? But unfortunately, it's no longer fit for the current reality, in the sense that at the center of this agent now, it's actually powered by these foundation models instead of by originally the symbolic AI kind of engine, okay? So there's a lot of tweak we have to do in terms of how to kind of adapt the programming model to this new reality world. And furthermore, this is not just in terms of how we code the things, but it's actually the whole technology stack in terms of how do we specify the different kind of domain level intent to how can we actually perfecting or make these various kind of software engineering tool usable to the underlying stack in terms of how we can actually make them actually faster, resource efficient, as well as more reliable. Again, all these things will be covered in the subsequent days for the weeks, so please stay tuned, okay? So in conclusion, I kind of showed you, foundation models is basically a black box without user manuals. So people have to do a lot of things to poke around to learn what's it good at and what's it not bad at, or what's it not good at. And people realized, by using model alone may not actually solve the whole problem. Instead, we have to shift our attention to this compound AI systems or agents. And I talked about various kind of representative research in this FM-powered agentware. And then I also presented a few of these research opportunities, okay? So before I conclude, there's going to be a special issue on AIware in the foundation model errors from the IEEE software. So the article is due on April 9th, so if you start right now, you actually have more than enough time, okay? So it was actually co-edited by me, Ahmed, Tom, and Mark. So I think it's a great opportunity to kind of showcase some of the work we have done over here. So that's all. Thank you.
Anybody has any questions? Thanks for the nice talk. It's just a curiosity. Where did the term foundation model come from? It came from the software engineering community or from the machine learning community?
The foundation model originally come from the AI community, right? Yeah. And sadly, they consider software engineering as one of its use cases. But again, every other field, it's the same for AI folks. Medical is one, chemistry is another one, and so on, right? So we are all considered as applications on top of this foundation model.
Great. Thanks for this great talk. Considering that the agentware here.
Oh, hi.
Agentware is going to be the future. So where do you see the organizations, how do you see the organizations manage bias and ensure AI augmented software aligns with the ethical standards?
Organization meaning the company organization or the organization of the agent themselves?
Company organizations.
Well, so there will be a certain area or certain responsibility which is better done by agents. So in other words, some of the jobs may be kind of more shifted toward these type of things, but there will still be a lot of other jobs, either kind of human employees and so on. They would work alone or collectively work with these various kind of agents. And just as a side note, right, so something maybe kind of related in a sense, right now Google just published their kind of Q3 earning report, and they already said, more than a quarter of their newly written code is generated by AI. And company from Anthropic, which is the close rival for the OpenAI, they mentioned, they don't think, AI currently can take over human engineers, but they feel it would be a nice supplement. But the more important thing is because of this, some of the job descriptions would actually be updated when they hire the human people, right? So in other words, these companies, the way I would see is they would see certain kind of positions which may be done by AI agent alone, maybe human be the people kind of overseeing the whole process, but there will be a lot of other positions done by human or mainly driven by human, but their skill sets would be very different from, currently people have, okay? Right. So we have to adapt to the new reality as well.
So the roles would change from what they are doing.
That's the way I see it, yeah.
Great, thank you.
Yeah.
Thank you for the talk. So you mentioned an amazing example of AI agent acting as a tax consultant and replacing QuickBooks. So my question is, how do we trust these AI agents to perform tasks, and how do we evaluate them?
Well, there are different levels of trust, right? So first of all, we have to write test cases. But you are using the AI folks' word called evals. So in other words, we need to kind of continuously curate a bunch of test cases. Maybe they needs to be static, or maybe some of them even have to be generated dynamically. That's one. And on the other hand, we need to have a lot of kind of oversight, either done by human, or nowadays a lot of research also done by AI. So in other words, another AI agent is going to review or oversee the whole process of whatever the task by the current agent. Because in many of these cases, some of the tasks can be too complex or too time consuming, and the scale may be too big for human. So it's better to kind of have the other AI to do that. And AI as a judge, I think, by the way, it's also a topic which will be covered in some, I don't remember which day, but it will be covered in this week as well, okay?
Thank you.
Another question. So things to me are evolving really fast. During my journey to Toronto, I was reading a paper from Ahmed about software engineering 3.0. He was envisioning software engineering 3.0, and now you are presenting software engineering 4.0 and then software engineering 5.0. So how you can cope with this velocity of changes?
I don't understand the question. Are you saying how do we shift from promptware to agentware, and how do we
yes,
shift
because
from
you are presenting a vision for 2013 that is software engineering 5.0, but AMED just published a paper about envision what would be software engineering 3.0. So it seems to me that the velocity in which all this stuff is evolving is really fast, and it's not so clear how we can deal with this velocity.
Oh, I see. Okay. So I answer this in two parts. Well, the first part is it doesn't mean everything is going to be redeveloped or readapted to this agentware. So in other words, some of the softwares, for example, like basic compilers and so on, will still remain as codeware. So the analogy you can think about, I think I mentioned that before, well, not in this, but in the previous FM plus SE, is this technology shift about the content consuming. So in the old days, we have radios, and somehow when TV comes out, people think radio is going to be taking over, which is not, right? So we still have car radio, and now people even saying that internet radio and so on. So these old things, they would not actually go away, especially for what it's good at, but it may be adapted to another form and so on. So in other words, on one hand, not everything will be shifted to this newer paradigm, but also on the other hand, that's something we need to actually think about as a whole software engineering research and practice community, is that programming model stuff. Because remember, the old nice principle we have in terms of abstraction and separation of concerns needs to rethink about. Saying this box, originally it was implemented by traditional codeware, right? Maybe it's better done by AI, so let's maybe create a nice abstraction on the top. Then, for whatever things change underlying stuff, then you can easily do that. Or maybe in some cases we use both of them depending on the scenario or the use cases, right? So that's why I was thinking probably the whole community have to rethink about what is the real type of software engineering kind of programming model, design pattern practices, or maybe even refactoring practices associated with this, okay?
Any other questions? Jack knows a lot more than he's telling us in this talk, so please feel free to ask more questions. We also have time.
Okay.
Thank you so much for the presentation. I'm curious about the example you showed earlier about 1 plus 1. You had some kind of math question asked to ChatGPT, and it kind of hallucinated a response. I'm curious how such kind of training that it can do, how does that scale to larger problems, and does it even scale? So if it can do this simple math reasoning, does it actually scale to being able to do reasoning over larger stuff? Because asking it this kind of simple stuff, it seems like we could just use a calculator to me, and yeah.
So first of all, let me answer the long-term view, which I kind of agree. So I think in one of these talks, which I think Sam Altman kind of talked about, saying the current technology is basically a rocket strapped to a dumpster, right? So in other words, you can go very far, but what it carries around is, something no idea, right? So that means people, even for those companies, don't think the current form of foundation models actually does things, right? So that's why we're saying, we likely, at least when we design software, we have to have these proper abstractions and separation of concerns to cope with that change if it comes, right? And second of all, the way currently solve it is basically by something called tool use. So if you're recognizing the context is related to math, then you switch to either the calculator or the Wolfram kind of math engine and so on to do it, which is similar to our brain, right? So if it relates to like, square root or exponent, you cannot do it within your head, right? So you use calculator, so tool use. So in other words, it's acting as a brain. So at least the current way of doing it, okay?
Thank you.
Yeah.
Hi. Thank you for the talk. So I'll just have I have a question about just your personal view on these things. So you said data is the new oil, and evaluating these models is really, really important. And there's one way of doing it is currently benchmarks that are openly available. So currently I've seen there's two ways of doing these kind of benchmarks and evaluation. One is people are trying to make closed source kind of benchmarks, and it's not publicly available. And some people they talk about if you use these closed source benchmark, how do we believe these companies are providing a very good evaluation of the model? And then the other version of this is this light code bench kind of example, where we continuously update the model, which is in itself is very tedious, and then it requires a lot of quality checks. And these when we keep updating them, we don't even know if we're gonna get a good amount of examples. So what do you think which would be in the future, what would be the best way to evaluate these models? Do we trust some sort of company, okay, whatever they say, which model is performing best is the best one, or do we still go on for the tedious one, where we quality check and we update our benchmarks with time, and then we just keep on checking the models? What do you think about these things?
Well, I think, to be honest, it will likely have both possibility coexist. So, for example, for the financial world, we always have some kind of private company like authorities to evaluate, how credible different institution or even different country is. So that's what the Moody and so on is, right? And they give you credit rating, and if you are kind of credible enough, people trust these kind of things, right? So we see various kind of startups, and maybe even probably include this Scale AI, which is also likely trying to do this Moody kind of credit rating, but in this AI context, right? So, and if this company is big enough, credible enough, because they have the resource and the knowledge to curate additional use cases, right? So we need that. But on the other hand, we need these kind of open source and the live one, because there's always a chance there may be some kind of new use cases or new scenarios people overlooked. So we basically have this independent or second eye to it to evaluate its capabilities. So sadly for me, I think there will likely be kind of both will kind of coexist in the future.
Thank you.
Well, people still have questions. This is a coffee break.
There's still time.
Thank you for the talk. I have a question, a complement to the question before the previous question about the reasoning on the math questions. So I have a talk with my supervisor, Dr. Peng Yu, and another professor from Harvard. We think the reason why, for example, ChatGPT doesn't perform well on math question is because they don't see a lot of the data sets from math question, the math examples. And how do you think about that? Do you agree? To what extent do you agree on that?
So that goes to the deeper root in terms of can large language model do reasoning, and different people have different opinion to it. Different people have different opinion on that. So if you're interested, I suggest you to look at the very recent kind of Apple paper, which they created a new benchmark called GSM symbolic. So in other words, kind of similar type of questions, but you swap with different numbers, and they just couldn't do it. And I don't think training alone can actually solve that, because in the sense, in order to solve one particular problem, you maybe have to show them hundreds and thousands of these examples. Not mentioning, we know in the real world there are lots and lots of these math problems. So I don't think that would scale. Maybe some kind of test scale inference, marrying with this kind of agentic workflow and so on. Maybe that's the way, because then we can actually infer and do these very kind of search and evaluation during runtime. At least it seems to me that's more feasible than kind of training on lots and lots more additional curated examples, because there are way too many math problems for us to kind of learn and train on.
So it's not a question, Jiang, but more a clarification. So there's software 1, 2, 3, 4, 5, okay? So that's just software itself. So remember I said we have to change software? We have to change software engineering. So the software 1, 2, 3, 4, 5, like the neural world, the agentware, all that, that's just the definition of what software is, right? We went from software that actually you had the code, you could debug it, it was physical in a way, right? Now it's, the AI is doing everything, okay? Then the other work, which we're gonna be talking about later today, which is how we build software, right? So traditionally we build software by having humans do the coding. The question is that the best use of humans' time, and should humans be used for other things more advanced, okay? Now, you can use software engineering 1, 2, 3 to build any of the software 1, 2, 3, 4, 5. So that's kind of the relation. I think that was the question you had, right? So I think we're gonna stop here. So let's first thank Jack for